Hello there. I had a gap of about 6 years between when I first took statistics as an undergraduate and when I got to take it as part of my master's degree. In that time, I forgot what a lot of these symbols that are used in statistics refer to, what they mean, and as I was relearning them, I kept wishing for some sort of single source where I could go and find the symbol, and that would allow me to cross-reference the name, and then I could go find it in my textbook index, or if I had the name, then I could go look up the symbol, and even just in some cases just to have the symbols present so that I could copy-paste them into a text document instead of having to go find the alt codes or the hex codes that would allow me to populate them into or a Word document. Anyway, that's what I've done here. I've broken this up into two different parts. The first are the Greek letters, the second are the Roman letters, and you'll see why I've made that distinction in a moment. So here I've begun with just the symbol and what we call the symbol. So over here, this symbol is alpha, this symbol is phi, symbol is rho, etc. Afterwards, I've gone ahead and defined what the term generally means or what the symbol generally means, or if there's not a succinct definition, I've gone ahead and indicated where it's used. So for alpha, it's our type 1 error rate, or the which we also call the significance level. But if we go down to eta, we see that it doesn't have as nice a definition. So I've gone over where it is. So we see it as eta squared, so the proportion of variance in the dependent variable that the independent variable accounts for. I've done this for the rest of the Greek symbols we used in univariate statistics as well. And then we get on to the Roman letters. So for the Roman letters, if they have a name that goes with them, I've included that. So the bolded D for Cohen's D, or P hat for the P with a little hat on top of it, or X bar or Y hat. If they don't have a name next to them, that means that they're pronounced the way that they look. So G is pronounced G, S is pronounced S, S squared is pronounced S squared. And again, I've gone ahead and given you a brief description of what each of these is. So if the bolded D is Cohen's D, so the effect size, G is an estimate of Cohen's D, so it's also effect size. The only real difference is that we don't use the exact same information to calculate it, and it's a biased estimator of D, meaning it's not quite where Cohen's D would be, but it's close, and in some cases is close enough for our purposes. Now for why I broke this up into Greek and Roman letters. Our Greek letters tend to be used for our population statistics. So if we were to measure how tall everyone in the world was, we would use our Greek letters mu and sigma, lowercase sigma, to indicate the mean and standard deviation for that person, or for that population, rather. For our Roman letters, we use them for sample statistics. So if we took a sample of 300-400 people out of the population, we would use X bar and S to refer to the mean and standard deviation. However, not all professors follow this convention, so it's important to check. An example of this is for the mean and standard deviation. Sometimes for our sample statistic, professors will use M to refer to the mean and SD to refer to the standard deviation. Just something to be aware of. Anyway, I hope that this is useful to you as I thought it would be useful to me while I relearned these statistics. And if you'd like me to go into more depth on any of these, let me know in the comment section below.